In this lesson, we're going to talk about a rhombus. We're going to specifically talk about the area and perimeter of a rhombus. Now, a rhombus is a parallelogram. It's a quadrilateral, and it's a quadrilateral in which all four sides are equal. But remember, it's still a parallelogram, so everything about a parallelogram is still true of a rhombus. What we want to look at here is the area. Well, first of all, let's start with a diagonal that we'll call D1. Now let's do this. Let's draw in the other diagonal, and let's call its length D2, little d2. And so I want to look at this half of it right up here. So that's D sub 2 divided by 2. So it's this diagonal divided by 2. Now I think I'll additionally erase this part down in here. And let's remember that this D1 refers to that whole length. Now, what is the area of this top triangle? It's the same as the area as this. So if I can find the area of this top triangle and double it, that's really the area of the entire rhombus. Well, the area of that top triangle is 1/2 the base, which is D sub 1, times the height, which is D sub 2 over 2. So this is really 1/4 D sub 1, D sub 2, where these two things are the lengths of the two diagonals. And remember, they're not equal in length. They're perpendicular, but they're not equal in length. Now, the area of the triangle, that was the area of the triangle. The area of our rhombus is 1/2, or rather it's twice the area that we have there. See, that area is this triangle here, but we have two of them. And so it's 2 times this. And the 2 times the fourth is 1/2. So here's our formula. Our formula for the area of a rhombus is 1/2 the product of the two diagonals. Now remember, it's still a parallelogram, so the old formula for the area of a parallelogram still applies. It's the area is the product of the base and the height. And sometimes the height is not given and it's difficult to find, but we might have to do it that way sometimes. We'll take a look at example 1. Let's see what we have to do here. It says find the area, the side length. Now all sides are equal in length, so we have to find just one of the sides, and that's all of them. The area and the perimeter. All right, it says that the diagonals have lengths 12 and 16, 12 and 16. So that's 8 and 8 because they bisect each other, 6 and 6. And remember too, and it's going to be significant in this problem, that the diagonals of a parallelogram, or the diagonals of a rhombus in this case, not only bisect each other, they do so in a perpendicular way. There's a right angle right there. All right, so here let's do this. Let's take this little triangle right here. Let's redraw it right over here. Okay, and so that's 6, that's 8, that's this triangle here. Here's the right angle that you see right here. And here's our side. Let's call our side x. Well, that's the hypotenuse of a right triangle. So we can apply the Pythagorean theorem. The Pythagorean theorem says x is the square root of 8 squared plus 6 squared. So that's 64 plus 36, and that's 100. And when you take the square root of 100, you get 10. So each side of this is 10. Now we can get the perimeter right now. The perimeter, all four sides are the same since it's a rhombus, so it's 4 times 10 is equal to 40. There's our perimeter very quickly. Now the area, what was the formula we just developed for the area? It's 1/2 the product of the two diagonals. There's a diagonal that's 16, here's a diagonal that's 12. So if we multiply all of that together, we're going to get 96. All right, so there are our answers. All right, for example 2, we're given this picture. It's a rhombus. We're given the diagonals drawn in there, and these halves of the diagonals are 5, 5, and 4, and 4. And we're asked, first of all, for the lengths of the diagonals. Well, that's the easiest. One of the diagonals, like this 5 plus 5. It doesn't matter which one you call D1 or D2. It makes no difference. And the other diagonal is 4 plus 4 is equal to 8. So we've got two of our answers right there. Now we're supposed to also find the length of a side. So diagonals of a parallelogram or of a rhombus bisect each other in a perpendicular fashion. So that's a right angle. So see this triangle right here? I'm going to redraw it over here like so. And that's 5 and that's 4. And that's the right angle. And here's the side that we're after. So this triangle here is this one. And the Pythagorean theorem will give us the length of the hypotenuse up there, which is the side of the rhombus. So it's 5 squared plus 4 squared is equal 25 plus 16 for the square root of 41. And so the square root of 41 is, put that on the calculator, and this is what I get, 40312. All right, now let's find two other things. The area, this is asked for in the problem. The area is 1/2 the product of the two diagonals. So it's 10 times 8. And so that would be 40 when that is multiplied out. There's our area. And then the perimeter is 4 times one of the sides. All 4 sides are equal. So 4 times one of the sides will get it. There's one of the sides there. And when that's multiplied, here's what I get. I get 25.61249. Try it and see if you get that. On example 3, we're not given a picture, we're just given these words. And here's what the problem says. A certain rhombus has an area of 100 square meters. If the longer of the two diagonals is 17 meters, how long is the shorter diagonal? Well, here's what we know. The area is 1/2 the product of those two diagonals. We're told that the area is 100. One of the diagonals has a length of 17. So this should be a pretty easy matter to find the other. So let's multiply both sides by 2. We get this. Now let's divide both sides by 17. And when we divide these two, that division gives 11.7647, and it's meters. Now remember, we were given this area is 100 square meters, so our dimensions are in meters. So there's our shorter diagonal. Notice that it's shorter than the 17, the longer one that we were given.